Hello students, welcome back to the maths class. In our last class, we have discussed some concepts about surface area and volume, and we have solved some problems from the exercise. Okay, in this class, we will move ahead and we will start with exercise 13.4. It says, assume pi is equal to 22/7, and question 1 says, find the surface area of a sphere of radius 10.5 centimeter, 5.6 centimeter and 14 centimeter. So, 3 radii are given and we need to find out the surface area of the sphere. So, let us begin with the first one. Radius is 10.5 centimeter. So, r is equal to 10.5 centimeter, and we know the surface area of the sphere is equal to 4 pi r square, and it has been instructed to take pi is equal to 22/7. So, when we replace the values, 4 into 22/7 into 10.5 square. Okay. So, after calculation, you will find the value as 1386 centimeter square. So, this is the surface area for the sphere of radius 10.5 centimeter. Okay. Let us go for the second one. Okay. Here r is equal to 5.6 centimeter. So, surface area is equal to 4 pi r square, that is 4 into 22/7 into 5.6 square, and that will give us a value which is 394.24 centimeter square. Okay. Now, let us go for the third one where the radius is 14 centimeter. Okay. So, the sphere number 3 has a radius of 14 centimeter, that means r is equal to 14 centimeter. Then surface area will be 4 pi r square, that is 4 into 22/7 into 14 square, and when we calculate, we will come up to a value that will be equal to 2464 centimeter square. Okay. So, this is the surface area of the sphere having radius 14 centimeter. This is too easy for you, isn't it? Because we know the formula for the surface area of sphere. When radius is given, it is just the calculation and we need to calculate correctly. Okay. Hope you understand. Students, question number 2 asks to find the surface area of sphere of 3 different diameter. We have already discussed how to find out the surface area using formula 4 pi r square. In this case, 3 different diameters are given. Okay. So, this you have to do by yourself, because you just need to find the radius of the given diameter and apply the formula 4 pi r square to find the surface area of the spheres. Okay. Just do it. Students, let us now solve question number 3. It says, find the total surface area of a hemisphere of radius 10 centimeter. In this case, it is instructed to use pi as 3.14. Okay. So, let us discuss the solution. What is given over here? The radius. Okay. So, r is equal to 10 centimeter. Okay. And total surface area, what is the formula? Total surface area is equal to 3 pi r square. Okay. That means 3 into 3.14 into 10 square, that is 3 into 3.14 into 100. (9.42) into 100, that is 942 centimeter square. Okay. So, the total surface area of the hemisphere of radius 10 centimeter is equal to 942 centimeter square. Is it too easy? Yes, because we know the formula, and if there is the radius with us, then we can very well find the total surface area of hemisphere. Students, let us now solve question number 4. It says the radius of a spherical balloon increases from 7 centimeter to 14 centimeter as air is being pumped into it. Find the ratio of surface areas of the balloon in the two cases. Okay. Hope you have understood the question. Let us now solve it. Okay. So, it is given that radius of spherical balloon was 7 centimeter previously and afterwards it is increased to 14 centimeter. So, let us take the radii as R1 and R2. Okay. So, previously it was 7 centimeter which when increased become 14 centimeter. Fine. What we need to do? Find the ratio. Okay. Find the ratio of surface area. What is the formula for surface area? 4 pi r square. So, in this case ratio of surface area is equal to 4 pi r1 square by 4 pi r2 square. Okay, that is equal to r1 square by r2 square, or it is 7 square by 14 square. Okay, 7 square by 14 square, it becomes 7 by 14 square, or 1 by 2 square, that is 1 by 4. So, that implies ratio is equal to 1:4. Okay. So, hence the required ratio is 1:4. Okay. Hope you understand. Students, let us now solve question number 5. It says a hemisphere bowl made of brass has inner diameter 10.5 centimeter. Find the cost of tin plating it on the inside at the rate of rupees 16 per 100 centimeter square. Hope you have understood this. There is a bowl made of brass. Okay. It has the inner diameter 10.5 centimeter and it is to be tin plated. Okay, from inside, and the cost is given for 100 centimeter square. Let us solve the question. Okay. So, what are the given data? The radius. So, we need to find out the radius. Okay. So, diameter is given as 10.5 by 2 is your radius and it is 5.25 centimeter. Fine. So, from diameter we have found the radius as 5.25 centimeter. Then we need to find out the surface area of the hemisphere. So, surface area is equal to 2 pi r square, that is 2 into 22 by 7 into 5.25 square. Students, when you calculate, it will give us a result of 173.25 centimeter square. Okay. So, we have found the surface area. Now, let us find the total cost. Cost of tin plating is equal to, what is it? Rupees 16 per 100 centimeter square. So, total cost, we need to find the total cost, but we have the surface area 173.25 centimeter square. Per 100 centimeter square, the cost is rupees 16, isn't it? So, for 173.25 centimeter square, it will be 16 divided by 100 into 173.25. Okay, 16 rupees per 100 centimeter square. So, per 1 centimeter square, it will be 16 divided by 100, and for 173.25 centimeter square, we need to multiply that value, and when we calculate, it will give us the value of 27.72. Okay. So, this is the total cost for the tin plating of the bowl. Okay. Hope you have understood this. Students, let us now solve question number 6. It says, find the radius of a sphere whose surface area is 154 centimeter square. So, let us solve the question. In this case, surface area is given as 154 centimeter square. That means 4 pi r square is equal to 154 centimeter square. Okay. So, 4 into 22 by 7 into r square is equal to 154 centimeter square. R square is equal to 154 into 7 divided by 4 into 22. So, 22 7s are 154, this becomes 49 by 4. So, R will be square root of 49 by 4, that is 7 by 2 or 3.5 centimeter. So, the radius of the sphere whose surface area is 154 centimeter square is found to be 3.5 centimeter. Hope you have understood this. Students, let us now solve question number 7. It says the diameter of the moon is approximately 1/4 of the diameter of the earth. Find the ratio of their surface areas. Okay. So, this is a question in which we need to apply our algebra part a bit because we do not have any value. So, let us take the diameter of the earth be d. Okay. Let the diameter of earth is equal to d. Okay. And what is the relation between the diameter of earth and diameter of moon? It is 1/4. So, diameter of moon will be d by 4. Okay. Now, if d is the diameter of earth, so here radius of earth will be d by 2 and radius of moon will be d by 8. Fine. So, we need to find out the ratio of surface areas of moon to surface area of earth. So, ratio will be equal to 4 pi. See, while finding out the ratio, you have to follow the proper sequence. It is asked to find the ratio of their surface areas. That means the surface area of moon to surface area of earth. So, what is the radius for moon? D by 8. So, 4 pi d by 8 square divided by 4 pi d by 2 square. That is equal to d square by 8 square into 4 by d square. That is 4 by 64 or 1 by 16. Okay. Hence, the ratio is equal to 1:16. Hope you have understood this. Students, let us now solve question number 8. It says a hemispherical bowl is made of steel 0.25 centimeter thick. The inner radius of the bowl is 5 centimeter. Find the outer curved surface area of the bowl. Okay. So, let us do the solution part. So, students, what is given over here? The inner radius of hemispherical bowl. So, inner radius is equal to 5 centimeter and thickness is 0.25 centimeter. Fine. So, what is the outer radius then? We need to add this thickness to the radius. So, is equal to 5 plus 0.25, that is 5.25 centimeter. Okay. So, now let us find the curved surface area of hemispherical bowl. So, curved surface area is equal to 2 pi r square, that is 2 into 22 by 7 into 5.25 square. Okay. And when we calculate, it will come up to 173.5 25 centimeter square. Okay. Hence, the outer curved surface area of the bowl is 173.25 centimeter square. Hope you have understood this. Students, let us now solve question number 9. Okay. It says a right circular cylinder just encloses a sphere of radius r. You can see the figure. Now find surface area of the sphere, curved surface area of the cylinder and the ratio of the areas obtained in bit 1 and bit 2. Okay. So let us go for the solution. Students, so what is given? Radius of the sphere is equal to r. Radius of the sphere is equal to r. Fine. Hence, surface area of the sphere, surface area will be 4 pi r square. Okay. For the solution of bit number 2, radius of the cylinder is equal to r. Of the cylinder is equal to r. Okay. Height of the cylinder is twice the radius. So, h is equal to 2r. Okay. So, curved surface area of the cylinder. Do you remember the formula for that? Hope you do so. Isn't it? It is 2 pi r h. So, curved surface area. Area is equal to 2 pi r h and we will substitute the value of h as 2r, that is equal to 4 pi r square. Okay. Now we have found the curved surface area of the cylinder to be 4 pi r square. Bit number 3 asks for ratio of the surface area of the sphere to curved surface area of the cylinder. So the ratio is equal to 4 pi r square divided by 4 pi r square, that is equal to 1 by 1 or in ratio 1:1. Hence, the required ratio is 1:1. Hope you have clearly understood this. Students, let us now discuss about volume of a cuboid. Okay. You have already learnt about volumes of certain figures in earlier classes. And what is volume? The measure of the space occupied by an object is called the volume of the object. If an object is solid, then the space occupied by such an object is measured and is termed the volume of the object. On the other hand, if the object is hollow, then interior is empty and can be filled with air or some liquids that will take the shape of its container. In this case, the volume of the substance that can fill the interior is called the capacity of the container. In short, the volume of an object is the measure of the space it occupies, and the capacity of an object is the volume of substance its interior can accommodate. For example, if I take a glass, okay, that means the amount of water or liquid that can be occupied inside the glass is the capacity of the glass, okay, but the amount of space the glass occupies is called the volume of the glass. Hope you understand. Okay. Students, the unit of measurement of either of the two is cubic unit. That means it is cubic unit for volume as well as capacity of the container. So, if we were to talk of the volume of a cuboid, we would be considering the measure of the space occupied by the cuboid. Further, the area of the volume is measured as the magnitude of a region. So, correctly speaking, we should be finding the area of a circular region or volume of a cuboidal region or volume of a spherical region, etc. But for the sake of simplicity, we say find the area of a circle, volume of a cuboid or a sphere, even though these mean only their boundaries. Okay. Students, observe figure 13.23 that is given in your book. Suppose we say that the area of each rectangle is A, the height up to which the rectangles are stacked is H, and the volume of the cuboid is V. So, can you tell what would be the relationship between V, A and H? See, the area of the plane region occupied by each rectangle into height is equal to measure of the space occupied by the cuboid. Let us just understand it. Okay. Students, let us now understand this concept using your math book. Okay. Students, this is your math book. So, just try to observe what each page looks like. Each page is a plane surface, isn't it? And it is rectangular as well. So, go to the last page. Okay. Now, this is the rectangular surface. When we keep on putting the pages one after another, all the pages are of same area and they are of same size, so they are having same area. What is happening? See, when we keep the book like this, we have these many pages one over another. So, they have certain height, they have gained certain height. So, this is your area of each paper, and after putting all of the pages together one over another, they have acquired a height, as you can see in your book. Okay. See, now this is the height. Now it is a cuboid. It is a cuboid. What is the area of the base? It is length into breadth, okay, which is now represented by A as per your book. Okay, and it has gained a height of H. Think about it. What we have done, we have added area of a rectangle one after another. So, just basic mathematics. 2 plus 2 plus 2 is equal to 2 into 3, that is 6, isn't it? So, same way, suppose area plus area plus area, they are going one after another and they are giving a height, or they have acquired a height. Suppose that height has been acquired by putting n number of areas. Okay. So, this n is nothing but the height. The number of rectangles one over another, they have constituted the height. So, the height multiplied by the area, that is h into a, gives us the volume. What is area? Area is nothing but length into breadth. So, we can write height into length into breadth is equal to volume, or this is represented as V is equal to L into B into H. Hope you have clearly understood why the volume of the cuboid is length into breadth into height. So, students, what we have found, the volume of a cuboid is equal to base area into height, or it is length into breadth into height. Students, when we measure the magnitude of the region of a space, that is the space occupied by a solid, we do so by counting the number of cubes of edge of unit length that can fit into it exactly. Therefore, the unit of measurement of volume is cubic unit. So, what happens in case of a cube? We know for a cuboid, volume is equal to length into breadth into height. But in case of cube, the length, breadth and height are all the same. So, if we take it as A, It is A into A, that is A cube. So, volume of a cube is A cube, where A is nothing but the edge, or it is the length, breadth, height. You can say it otherwise, okay, because length, breadth, height, that means the edge of cube is all the same. The volume is equal to A cube. Hope you understand this. So, students, if a cube has edge of 12 centimeter, then volume of the cube is 12 into 12 into 12 centimeter cube, that is 1728 centimeter cube. Okay, students, let us now discuss example 11. A wall of length 10 meter was to be built across an open ground. The height of the wall is 4 meter and thickness of the wall is 24 centimeter. If this wall is to be built up with bricks whose dimensions are 24 centimeter into 12 centimeter into 8 centimeter, how many bricks would be required? Now, let us discuss the solution. Since the wall with all its bricks makes up the space occupied by it, we need to find the volume of the wall, which is nothing but a cuboid. So, what are the given data? Length, that is 10 meter centimeter. Okay. Thickness, what is thickness? It is nothing but the breadth, is equal to 24 centimeter. And height is given as 4 meter, that is 400 centimeter. Fine. So, let us now find the volume. So, V is equal to length into breadth into height, that is equal to 1000 into 24 into 400. Okay. So, the volume of the cuboid is 1000 into 24 into 400, that is equal to 96,000,000, that is 96 lakh centimeter cube. Okay. Now, you might be thinking, why in your book it is given as 1000 into 24 into 400 centimeter cube? Because we need to find the number of bricks. So, in a later stage we need to divide the volume by the volume of each brick. So, it will be easier for the calculation, not to worry. Okay. So, now let us find the volume of each brick. Okay. What are the dimension of the brick? The brick is of length 24 centimeter, breadth that is equal to 12 centimeter and height that is equal to 8 centimeter. So, volume of each brick will be length into breadth into height, that is equal to 24 into 12 into 8. 168 into 8, 1324 centimeter cube. Okay. You can solve for the volume part by calculation, or you can leave it as 24 into 12 into 8 for easier calculation purpose. Okay. So, let us find the number of bricks. Okay. So, number of bricks required, number of bricks required. So, number of bricks required is equal to volume of the wall divided by volume of each brick. So, let us calculate in a easier way, that is equal to 1000 into 24 into 400 divided by 24 into 12 into 8. Okay. So, 24 or 24 we can cut it out, then 50, that means 50,000 divided by 12, and we will get a decimal value of 4166.6. That means when we round it off, it will be 4167. So, number of bricks required will be 4167. Okay, hope you understand. Students, this is the end for today's session. In this session, we have discussed some concepts about surface area and volume, and we have gone through some examples and solved some questions. In our next class, we will discuss some more concepts about surface area and volume. Till then, keep practicing, keep smiling. Thank you.